Hi, this is Purnima Magalingam, and you're watching video lecture series on power system protection and switchgear. Today, in this video, we are going to discuss about the fault current calculations. Come, let's go to the video. Here comes the fault current calculations. So here, what happens it is we have two types of fault. We know that one is symmetrical fault, next one is asymmetrical fault. We have know that this is what an fault current we are going to calculate. Now coming to analysis, fault current analysis, we have analysis type. We have two types of analysis. One is power flow analysis, next one is fault analysis. So power flow analysis, here comes the normal operating conditions. What is the flow of power, etc. etc. Next is fault condition. When fault occurs, what happens? If abnormal conditions occurs, what happens? What is the calculation of current, value of current? So we are calculating the two types of current. One is in normal condition, next one is in abnormal conditions. And we already know that we have three types. We have already know that we have types of fault. We one is symmetrical fault and unsymmetrical fault. So here is the symmetrical fault is a three-phase short circuit fault, and that is balanced or symmetrical fault that mostly appears in three-phase supply systems. So next one is unbalanced fault or unsymmetrical fault. So that occurs in single line to ground. We know that in double line to ground and line to line fault, single line to ground fault, double line to ground fault, etc. So these are the things we need to know before calculating the fault analysis. And next is various types of faults. First we have seen that various type of fault. First one is symmetrical fault. So I already have told that symmetrical fault occurs only in three-phase systems. So here we have seen the three-phase systems. So phase A, phase B and phase C. Here we can see the three-phase system fault. Fault occurs in three-phase system. That is in a balanced. It occurs in all the three phases. That is what in symmetrical systems. Here comes the symmetrical systems. The fault in three-phase fault is Vf divided by Z1 plus ZFA. And unsymmetrical fault. So unsymmetrical fault, it occurs in line to it also known as line to line fault, double line to ground fault, and line to ground fault. So line to line fault. So the fault occurs between the two lines. The fault occurs between these two lines is known as line to line fault. And when the fault occurs between the double line to ground. So the fault occurs between the double line to ground is a double line to ground fault, and line to ground fault. So line to ground fault means one line to ground, maybe phase A or phase B or phase C. So line to ground fault. Okay, this is what an unsymmetrical fault. Now coming to RLC transient circuits, we know that this RLC transient circuit, we have a power supply, we have a resistor, we have inductors, and we have a switch. So we have already know that the equations, transient equations, symmetrical fault. Finally, we are finding the impedance Ez, and finally we are finding the value of transient analysis value, and coming to the asymmetrical faults. So this is one analysis of asymmetrical faults. This is the current value, and whatever happens, it comes in as DC offset magnitude depends upon the angle alpha, and in order to get the largest fault current, set alpha is equal to theta, theta minus pi divided by 2, theta minus pi divided by 2. Theta is an angle, phase angle, divided by pi by 2. So I of t, the transient current I of t is equal to I of t, and finally we are getting this value. So theta is omega t plus pi by 2 is an analysis. And here we are coming it is we have four methods to calculate the fault current. One is ohmic method, which is a not perfect method, and next one is infinite bus method. That is infinite buzzer method, that is a convenient and easily calculations, and per unit method is the most commonly used method, and the MVA method is a quick and easy method. We have four methods. One is ohmic and infinite buzzers, per unit methods, and MVA methods. And now coming to next one is uh, fault current analysis per unit method. This method requires the knowledge of symmetrical components like positive sequence, negative sequence, and zero sequence. So we know that we have an sine wave here. It's in a positive sequence, and this is what a negative sequence is in a zero. So it's a positive sequence. This is one negative sequence. This is in a zero sequence. So interconnecting positive, negative and zero connecting network, calculating the various unsymmetrical faults like line to ground fault, line to line fault, and three phase fault. Finally, we are coming to summarize that when power systems fault occurs mainly depend upon the natures, and we have discussed about the causes of the fault. We have discussed about the types of faults, and here comes the analysis. How we are analyzing the fault current. Here we analyze that the system component by the positive or negative or zero sequence and per unit systems and Thevenin's equivalent circuits and bus impedance methods. So these methods we are analyzing the fault. I hope you enjoyed this video. Thank you so much.